Hi, I'm Daniel McDonald, and alongside my colleague Zhao Fan, we're going to talk to you about updates in automated planar geometry in the Wolfram language. Right, so we're going to give updates about our automated geometric functionality from the past year, including the addition of the plot theme option, as well as support for graphics options for styling geometric scenes, um, as well as updating formatting and dynamic capabilities of geometric scene, and the addition of the function GeometricSolveValues for solving quantities in abstract scenes. So we'll start with GeometricSolveValues. So at our talk last year, we um, mentioned GeometricSolveValues and said that it was making its way into the language, and it has arrived. So let's again give a few examples about how to use it and how it works. So let's start with solving for the area of a quadrilateral. So remember, geometric scene allows you to define an abstract scene without inputting in any coordinates for the points. So this first argument is a list of points. The second argument is a list of hypotheses that describes the scene. So let's evaluate this. And then if we want to visualize the scene, random instance will find coordinates for the points that make them satisfy these hypotheses. So let's um, run random instance. And again, random instance is random. So if we run it again, we should get a different scene that nonetheless satisfies these constraints. Okay, and then we can solve for the area of the quadrilateral. So notice we're putting in um, the abstract scene here, not the scene instance. So GeometricSolveValues is finding the area of the P based on just this abstract scene. And so we run this, and eventually it will evaluate to 48 square units of area. So let's try another example, this time with the triangle. So again, we define this abstract scene. Here we've got points A, B, and C, and this quantity X. And here we are assigning coordinates to points A and B and the Y coordinate for C, but we are leaving its X coordinate X to be variable. And then we can also find a random instance of this scene. So if we want to compute the area of this particular triangle above, we can plug in this instance into GeometricSolveValues, and it'll give us the area of this particular triangle. But notice that the area depends, in the abstract scene, depends on X. So if we get a different random instance of this triangle, we should presumably get a different value for the area of the polygon, and indeed we do. So if we want the area of the polygon for any value of X, then we need to plug in the abstract scene and solve for the area. And if we do that, we see that it's 2 times X. And our last example here, we've got a right triangle where we know the lengths of its legs, but not its hypotenuse. So again, we'll run this and get an instance of this triangle. So if we're wondering how GeometricSolveValues works, well, first we have to find some algebraic formulation of the abstract scene, to solve for whatever quantities we're solving for. So if you want the abstract formulation, that's available as a sub-value of this scene. So if we look for the abstract formulation of the scene, we get this logical conjunction of equalities and inequalities involving the coordinates of the scene as well as h, which is our hypotenuse, and which we eventually want to solve for. So if we want to solve for h, in this case, we can either use solve values on this algebraic formulation, or we could use geometric solve values directly on the scene. And so we'll do those both at the same time. And eventually we get the same answer for each, unsurprisingly, square root of 5. Okay. And now on to updates for sort of the formatting of GeometricScene. Now we allow the dynamic adjustment of values of a declared quantity in a scene, whereas previously you could only dynamically adjust the position of points. So let's look at an example. So here we've got a polygon, and we're specifying in our abstract scene that the ratio of the perimeter of the polygon to the area of the polygon equals some quantity r, which is at least 1. And for scaling purposes, we're putting the polygon inside of a circle. So we have this random polygon in here. So if we wanted to move points around, we just drag the points, and we get a new polygon. Notice that the dragging by dragging point D, that does not guarantee that these A, B, and C stay in the same position. If you want the other points to stay in the same position, then you click on the scene, not on a point, and we can, if we say we want B and C to stay fixed, and we click on those, and then when we drag D, B and C stay perfectly fixed. So this we've been able to do for a while, but what's new is now if we want to dynamically adjust this quantity R, which is here is the ratio of the perimeter to the area of the polygon, then click on the scene outside the points, and we'll let B and C move again, and then we can drag the slider here to change the value of R. And so R gets bigger. That means that this ratio of perimeter to area gets bigger, which means in a sense we're sort of getting further and further away from being a square. And if we drop it back down a bit, then this ratio gets a bit smaller, and we get closer to being a square. So anyway, so now we can dynamically adjust quantities as well as as well as point positions. Okay, at this point, I am going to hand things off to Xiaofan, who will talk about how to style geometric scenes using both the previously available methods as well as our new options of plot themes, as well as options inherited from graphics. So thanks for listening to me, and hope you continue on to listen to Xiaofan.
Hello, everyone. I'm Xiaofan, and I will give you an overview of the ways to style GeometricScene instances. So the first way is to use this style function. Here is the example. As we can see here, we just wrap this style function over the shape that you want to style. And this example is to showing that we are styling this polygon into purple. And we can also style a specific point, as this example here. Notice that this point is set to be red. It's just only changing the color of the point, but not to do anything with the letter. And to style the letter itself, we will have to use this font family, font size, etc. And we can also style a line here. So basically, you can wrap this style function over any of the shape, any of the point in the second argument of GeometricScene. So that's just how to style a single shape. And we are moving on to how to style a type of shape altogether. So yeah, we have this geometric styling rules option that they can control one style of the shape altogether. So here, as we can see, this geometric styling rules option, it contains this point style, styling patterns, and conclusion style. We can just go over it one by one. So here, this point style is controlling all the points all together, and then they're set to black. And I believe you can also make some changes to the letter font here, letter options here. And for this second one, styling patterns, here we can see this underscore circle through. This means that all of the shapes that is matching, starting with the circle through, will be selected here. We only have one circle here in this scene, but if we have more, let's just say 3 or 4, and then this circle through, we'll just pick them all together and shape all the 3 or 4 to red. And then for the last one, the conclusion style, this one controls the third argument of GeometricScene, as here. So it was just setting this planar angle to purple, and since it's 90 degrees, it's a right angle, so we have the right angle mark here. And for this one, this is new in 14.1, this graphics options. So for the previous examples, we are styling more on the scene itself, like the shape, like the points. For these graphics options, they are controlling more on the whole aspect of the graph. Like we can add a background, add grid lines and plot labels, and more controlling of the plot labels. So you can refer to the documentation center page for graphics to see there are more options there, and then you can just try them in GeometricScene. So yeah, and another new thing in 14.1 is that we have this PlotTheme option, which is just a combination way of all of those before, and then we just pack them all together. So it's just automatically add curated sets of the above styling elements, and I will show some examples on the next page. So yeah, here, use PlotTheme option in GeometricScene. Here we have this example of the scene. and this is the syntax. So basically you have one scene, and you just name the plot theme you want to use. And then these are the options for the plot themes. I'll just give an overview. So plot theme is an option in graphics. And for these ones, there are the options for original plot theme. And then we are just curating the styling for GeometricScene to match the coloring of the original plot theme. But for like these three, the textbook, black, white, and no point labels, as we can see down here, they are specifically curated for GeometricScene to use, because as we know that plane geometry is more used in textbooks. So we're just keeping the colors away and keep it simple for a better representation for some educational purposes. But yeah, you also get these colorful ones. So this example is showing that we can combine some of the scenes or some of the plot themes together. Here, the example is just to put this no point label, combining that with all of other scenes. So basically the same thing, just taking all the points out as the name. So yeah, here are the examples. So we can also combining all of the styling ways mentioned above. So here we put in the plot theme black white, which means that this whole thing should be black and white. However, when we have other style options, then they take different priorities. And then there's geometric styling rules, point style. It's setting all the points to blue, and then adding the background as light blue. Here, the style, the point B to red is taking the priority. So yeah, you can combine all of these options to just style the scene specifically for you to use for educational or presentation styles. All right, that wraps up our talk for today. Thank you for listening, and we really appreciate your attention and support for the synthetic geometry project. And there will be a live Q&A session right after this. Thank you.
We'll stick around if there are any questions. Otherwise, have a good weekend, everybody.